Hello guys, my name is Susana from Sri Venkateshwara College of Engineering. Before starting topic, please like, subscribe my YouTube channel. Today's topic is research point of application in normal distribution. Introduction, mathematical foundations and predictability, probabilistic interpretation, standard normal distribution, fundamental statistical concept, standardized testing, quality control and manufacturing, and conclusion. First is mathematical foundation predictability parameters. The normal distribution is characterized by two parameters, the mean and the standard deviation. These parameters allows you to describe the entire distribution, making it useful for prediction and decision making. Applications. Understanding these parameters is crucial in industries like manufacturing, where control of production process depends on minimize deviation from the desired mean. Probabilistic interpretation area under the curve. One of the first application in introductory normal distribution is calculating the probabilities. The total area under the curve represents a probability of 1, which allows the calculation of probabilities for different outcomes. Applications. In real life, this is used for risk analysis in finance. Example, determining the probability of stock price falling within a certain range of or accessing pass or fail rates in exam based on cutoff scores. Next is standard normal distribution z-scores. The introduction of the standard normal distribution mean equals to 0, standard deviation equals to 1 allows for easy calculation of probabilities and compromise between data sets. Z-scores represent how many standard deviation a value is from the mean. Application. This concept is applied early in social science, physiology and quality control processes, where standardization across different measures or data set is required. Fundamental statistical concept. Introduction to statistical concepts. The normal distribution serves as a concurrent in statistics. It is often of the first distribution thought because of its importance and prevalence in real world data. Application. Understanding the normal distribution helps students grasp broader statistical concepts, which are foundational for data analysis, research design and interpretation of statistical results. Next is standardized testing, test score interpretation. Many standardized tests, example STAT and ACT, assume that scores are normally distributed. This allows for meaningful compromises or individual scores against population averages and preference. Application. This application significant in education policy and college admissions, where understanding the distribution helps to evaluate student performance and readiness. Quality control and manufacturing. Six Sigma methodology. Many quality control processes rely on the normal distribution to identify the variation and improve the production efficiency. Control charts often assume that process data follows a normal distribution. Example, a manufacturing plant can monitor the dimensions of produced component using normal distribution techniques to maintain the quality and minimize defects. Properties of normal distribution. Symmetry. The normal distribution is symmetric around its mean. This means that the left and right side of the curve are mirror images of each other. Bell-shaped curve. The shape of the curve is determined by the mean and standard deviation. A small standard deviation makes the curve steeper and narrower, while a larger standard deviation makes it flatter and wider. Mean equals to median equals to mode. In a normal distribution, the mean, median and mode are all equal and located at the center of the distribution. Asymptotic behavior. Details of the normal distribution extend infinitely in both directions but approaches the horizontal axis asymptotically asymptotical, meaning they never actually touch the axis. Unimodal. The distribution has one peak mode which occurs at the mean. Limitations of the normal distribution despite its widespread use. The normal distribution is not always applicable, particularly in cases where the data exhibits non-normal characteristics. Some of these limitations include a fat tail and heavy tail distribution. The normal distribution is light-tailed, meaning it underestimates the likelihood of extreme values or outliers. Many real-world phenomenon such as financial returns or natural disaster exhibit fat-tailed or heavy-tailed behavior. For such data distribution, like they or T distribution are more appropriate. Extreme value theory is often used in finance and meteorology to better model these rare events. EVT uses distribution especially designs for extreme data points which the normal distribution cannot capture well. Conclusion. The normal distribution serves a fundamental element across various fields, providing essential insights into data behavior and facilitating informed decision making. Its application extends from biological science to finance, quality control, and social research, demonstrating its versatility and importance in statistical analysis. Understanding the normal distribution enhances researchers' ability to interpret the data and drive meaningful conclusion, making it a critical topic in statistical education and practice.